Hi everyone, welcome the video lecture on circuit analysis. In the last session, we have seen how we can apply the Kirchhoff's law in addition to the Ohm's law. That means how we can apply Kirchhoff's voltage law and Kirchhoff's current law. Okay, so and we have also solved certain exams. Now let's to be clear some pointers. Let's solve these examples. Okay. So for the first circuit, that means which is represented by circuit 1, it says find V naught and I naught in the circuit given below. So as you can see here, this is a circuit. This is the circuit. Okay, this is the circuit. So as you can see, the circuit has three elements, three components, one dependent current source. This is a dependent current source, and this one is the independent current source, and this one is one passive element, which is the resistor. So we are asked to determine the current I naught and the voltage V naught. Okay, V naught, which is across the 4 ohm resistor, and I naught across, passes through the 4 ohm resistor. Okay, so to solve this, just we can apply KCL. Just the application of Kirchhoff's current law can be applied so that we can solve I naught and V naught in addition to the Ohm's law. So for this circuit, we have two nodes. This is the first node. As you can see, three elements are connected together, and this one is the second node as well. That is also the same elements will be connected on the other terminals for the circuit elements. Okay, so these nodes are actually the principal nodes because the three elements are connected. That means when we are saying principal nodes, when three or more elements are connected to a node, so that node is we call it principal node. When two elements are connected at one node, so that node is basically, we call it a simple node. So as you can see, this is a principal node. So let's apply either of the nodes. We can apply KCL. Okay, so we can have apply KCL for this solution. Apply KCL at node A. Okay, at node A. So as you can see here, the 5 ampere, the 0.5 I naught is entering the node A, and I naught and the I naught it is leaving the 0.5 I naught and 3 ampere are entering the node. That means 0.5 I naught and the 3 ampere current source are entering the node. Okay, Okay, and the other one is I naught that is leaving the node. Okay, leaving the node. So we have said that KCL says that the sum of the current entering the node, which is equals to the sum of the current leaving the node. So the sum of the current entering the node is 0.5 I naught plus 3, which is equals to the sum of the current leaving the same node is I naught. Okay, so 3, which is equals to I naught minus 0.5 I naught. So 3, which is equals to I naught minus 0.5, which is I naught over 2. So from this, I naught, which is equals to 2 times 3, which is 6 ampere. So from this, by applying Ohm's law, we can have V naught, which is equals to 4 times I naught. So 4 ohm times 3 ampere, which is equals to 12 ohm ampere, which is 12 volt. Okay, so using this, we can have the solution just by applying KCL and Ohm's law. For the same circuit, for circuit 2, which is number of elements are connected. So for this circuit, as you can see here, This is a sim and node. This is a node, and the other one is another node. So okay, so this circuit has also two nodes. So we can have this is node 1 and this is node 2. Okay, node 2, and it has consisting of four elements. The 6 ampere current source, the 2 ohm, and the 8 ohm resistors, and the I naught over 4 dependent current source. Now let's apply KCL. Apply KCL at node 1. Okay, at node 1. That means, as you can see here, 6 ampere current source is entering the node. Okay, so 6, which is equals to I naught, it is leaving, so I naught plus I naught over 4, it is leaving the node, and which is plus V naught. Let's say this is the current entering the 8 ohm resistor, so V naught over 8. V naught over 8. Now let's consider V naught, which is equals to twice of I naught, because as you can see, this element is in parallel with this element. So of course, all elements are connected in parallel, so the voltage across the 4 elements will be the same, and the voltage across this 8 ohm resistor will be twice of I naught. So let's substitute I naught, which is plus I naught over 4 plus twice of I naught over 8, which is equals to 6, okay. So this is how we develop the equations, okay, the equations. So we can have 6, which is equals to the common, which is I naught common 1 plus 1 over 4 plus 1 over 4. Okay, so 6, which is equals to I naught into 4 plus 1 over 4. Okay, so 6, which is equals to I naught into 6 over 4. Okay, so 6 will be cancelled. So from this, I naught, which is equals to 4 ampere. Okay, 4 ampere. So using this, I naught is obtained. So, but just by applying Ohm's law and KCL, Okay, so now let's consider, just by applying Ohm's law from this expression, V naught, which is equals to twice of I naught, okay, twice of I naught. So which is 2 times 4, which is equals to sorry, so we can have V naught, which is equals to twice of I naught, which is 2 ohm times 4 ampere, which is equals to 8 ohm ampere, which is 8 volt. Okay, the voltage across the 8 ohm resistor will be 8 volt. Okay, so the current will be in the 8 ohm resistor will be 1 ampere. Okay, now let's consider this circuit. Okay, find the currents and voltage in the circuit given below. So we have the current directions we have given I1, I2, and I3. Okay, I3, and we are asked to determine V1, V2, and V3. Okay, and the circuit total consisting of 5 elements, 2 voltage sources, and 3 resistors. So the circuit has a number of nodes. This is 1 point. This is a node. This is another node. This is another node. This is another node. Okay, this is another node, and this is also another node. So, which is the circuit has totally 4 number of nodes. So node 4 and 2, they are the principal node, whereas node 1 and 2, they are the simple nodes, because they are connecting only two elements. At node 1, 5-volt voltage source and 2 ohm resistor is connected. At node 3, 4 ohm resistor and the 3-volt voltage source will be connected. Whereas at point 2, 2 ohm resistor, 4 ohm resistor, and 8 ohm resistors are connected. So that's why it is a principal node. And node 4, it is 5 volt, 8 volt, and 8 ohm and 3 volt sources are connected together. So that's why it is a principal node. Okay. Now let's consider how we can determine the expression for determining the current I1, I2, I3, and V1, V2, and V3. So we are going to apply both KVL, KCL, and the application of Ohm's law. Okay. Now let's apply KCL at node 1. At node 2. That's the principal. So, okay. So for this case, we can write I1, which is equals to I2 plus I3. Let's say this is equation 1. Okay. So from Ohm's law, we can write V1, which is equals to twice of I1. From this, I can write I1 is equals to V1 over 2. V2, which is equals to 8 I2. From this, I can write I2 is equals to V2 over 8. Okay. V3, which is equals to 4 I3. From this, I can write I3, which is equals to V3 over 4. Okay. So using this, we can substitute to equation 1. That means I can write I1 instead of I1. I can write V1 over 2, which is equals to, instead of I2, which is V2 over 8 plus V3 over 4. So let's multiply both sides by 8. So you will have 4 V1, which is equals to V2 plus twice of this. So this is equation 2. Okay, equation. Now applying KVL. For this is, let's say, loop 1, and this is loop 2. So let's apply KVL for loop 1. Let's apply KVL for loop 1. Okay, so that means we can write 5. That means the sum of the voltage across the loop will be 0. So I can write 5 minus V1 minus V2, which is equals to 0. So from this, I can write V1, which is equals to 5 minus V2. Let's say this is equation 3. And let's apply KVL again. Apply KVL for loop 2. Okay. So I can write the sum of the voltage across the loop 2 will be 0. Okay. That means V2 minus V3 plus 3, which is equals to 0. Okay. So minus V2 plus V3, which is equals to 3. This is equation 4. Okay, equation. Now substitute equation. Okay, substitute equation 3 into equation 2. Okay, equation 2. That means equation 3 should be substituted into equation 2. That means you'll have 4 into, instead of V1, I can write this expression 5 minus V2, which is equals to V2 plus 2V3. Okay, 2V3. So from this expression, I can write 5V2 plus 2V3. to V3, which is equals to 20. So this is equation 5. This is equation 5. Okay, equation 5. Now let's solve equation 5 and equation 4 simultaneously. That means we have equation 4. Let's have equation 4. That means minus V2 plus V3, which is equals to 3. That is equation 2. And equation 5, that is 5V2 plus 2V3 plus 2V3, which is equals to 20. Okay, let's solve this simultaneously. Okay, so let's multiply by 5. So you'll have minus 5V2 plus 5V3, which is equals to 50, and 5V2 plus 2V3, which is equals to 20. So let's add together. Okay, so this will be cancelled. So you have 7V3, which is equals to 35. Okay, so V3, which is 35, divided by 7, so which is 5 volt. 5 volt. Okay, 5 volt. Now consider equation 4. Consider equation 4 again. Consider equation 4. Okay, equation 4. That means minus V2 plus V3, which is equals to 3. So let's substitute V3 by 5 minus V2 plus 5, which is equals to 3. So minus V2, which is equals to 3 minus 5. So V2, which is equals to 2 volt. Okay, 2 volt. Let's consider equation 3. That means V1, which is equals to 5 minus V2. So V1, which is 5 minus 2, which is equals to 3 volt. 3 volt. Okay. Which is 3 volt. Okay, 3 volt. So from this I can write V1, which is equals to 3 volt, and V2, which is equals to 2, and V3, which is equals to 5 volt. Okay. 5. Now let's find I1. I1, which is equals to V1 over 2, which is 3 volt over 2O, which is equals to 1.5 ampere. I2, which is equals to V2 over 8, which is equals to V2 is 2 volt 8O, which is equals to 1 over 4 ampere, which is equals to 0.25 ampere, and I3, which is equals to V3 over 4. V3 it is 5 volt over 4O, which is equals to 1.25 ampere. Okay, so from this I1, which is equals to 1.5, and I2, which is equals to 0.25 ampere, and I3, which is equals to 1.25 ampere. Okay, so that's how we can apply the Ohm's law, Kirchhoff's voltage law, Kirchhoff's current law. Okay, and we can determine by application of these laws the voltage and current through the elements in the circuit. Okay, so that's all for this session. So please subscribe, share, and like the video so that it will be accessible for others. Thank you very much.